So this unit is on quadratic relations, and we're going to learn three different forms of representing a quadratic relation algebraically. The first of which is the vertex form. And just before we get into talking about the vertex form, the Minds On section for this lesson talks about just a general look of a parabola and what a parabola is. So whenever we graph a quadratic relation, you're going to get a shape that looks like a U that we call a parabola. And these parabolas have certain properties. So let's look at a parabola. So here's a parabola, and I've labeled certain properties on this parabola, and we'll talk about each of them. So the first of which is that a parabola itself can open either up or down. And in this image we see here, the U shape is opening up. So this would be a parabola opening up, of course. And the property that would represent if it opens up or down would be the sign of the number, the coefficient of the x squared term. And if that sign is positive, it opens up. If that sign is negative, it opens down. The next thing to talk about for a parabola would be that if it crosses the x-axis, the points where it crosses the x-axis are called zeros. So it's possible to have a parabola with two zeros, like the one we see here. It's also possible for a parabola to have 1 0 if the vertex is on the x-axis. And it's possible to have a parabola that has no zeros if the vertex is above the x-axis and it opens up, or if the vertex is below the x-axis and it opens down, we would have no zeros. The axis of symmetry is a vertical line that goes through the vertex and separates the parabola in half symmetrically. So if we fold the left side of the parabola onto the right side, it would be exactly the same shape that we would see. So that's called our axis of symmetry. The optimal value is the y value of the vertex, and it's either a maximum or a minimum. So if we have a parabola that opens up, the optimal value will be a minimum because that's the lowest possible value that the parabola can be. And if we have a parabola that opens down, the optimal value will be a maximum because that's the highest possible value the parabola can be. Lastly, just with any kind of waveform, any function that is a wave, it will have a y-intercept if it exists along the y-axis. And for a parabola, the y-intercept can be found by substituting 0 in for x, just like it can be found for doing any other type of function. So one way of representing parabolas algebraically is this vertex form. And the vertex form, you can see, is listed as y equals a bracket x minus h bracket squared plus k. That is our general form of a parabola using what we call vertex form. And the reason why we call it vertex form is because the h and the k can be used, or reading from the equation, the h and the k would then be the vertex of the parabola. So h is the x component of the parabola, and k is the y component of the parabola, or of the parabola's vertex, I should say. Now notice that it's always subtract h. So that means that if we have x minus 3, for example, then our h is 3. But if we have x plus 3, then that means that our h would be negative 3. Because if we have a plus sign there, that means that the only way we can have that be a plus is if the h is negative, and we were subtracting that. Another thing that we didn't mention in the image, though, is the step pattern. So the step pattern is a way of, it's a property that is used to help graph the parabola, and it is a pattern that is always equal to the leading term or leading coefficient, so that coefficient of the x squared term, the a, and then it basically follows this same pattern. It goes a, 3 times a, 5 times a, 7 times a, and on and on and on like that. And what the step pattern means is that as we move one horizontal distance to the right or left of the vertex, the parabola will increase by a. And then if we move one horizontal distance to the left or right from that point, we get to our next step, which increases by 3 times a. And then one step to the right again or left again is 5 times a, and so on and so on. So what we see here is a parabola, and this parabola is graphed using the step pattern. So I'll move it down a little bit just so we can see the axis, the y-axis, or the x-axis and the y-axis. So our vertex is at 6, 2. If we move one to the right, we get to 7, and it increases by a. And in this case, our a would be 1. So we move up by 1 when we move right by 1. The same thing happens if we go to the left. So if we go to 5 on the horizontal axis, we would go up by a on the y-axis. So we go from 6, 2 to the next 2 points, which would be 7, 3, and 5, 3. Now let's go right once more. Now we would go up by 3a. So if we go right again, from 7 we go right and we get to 8. And then we go up by 3. So from 3 plus 3, we go up to 6. Going the other side on the left, we go from 4 to 3, but we go up by 3. So we end up at 3, 6 on the left. Sorry, I should have said 4, 6. I've been reading it a bit wrong. 4, 6. And on the other side, it's 8, 6. And now if we go once more, we're going to go up by 5. So from 8, 6, if I go to the right, I get to 9, 11. And from 4, 6, if I go to the left, I end up at 3, 11. So this helps us graph the parabola using this step pattern. We use it quite a bit in this unit, so if you're having trouble understanding it, feel free to email me. I know it might be new to quite a few of you. So now we'll talk about how to sketch the parabola. When we have a parabola in vertex form, the first step really is to find out what the vertex is. And this form is usually easy to find that because we just we see what our h is, we see what our k is, and we label our vertex. So using our hk, we find our vertex. The next thing we do is we look for that leading term in front of the x squared term, or the bracket. And that tells us our first step. So if that term is a 2, our first step is 2. If that term is minus 3, our first step is minus 3. So we basically go from our vertex, we go one to the left or one to the right, and we move up or down based on what our a term is. And then it's good to label another point. So we should maybe go to the second step, which is 3 times a, as we go one to the left or right. And then basically we would end up with you should have 5 points, and that should be enough for you to sketch the curve of the parabola. If you'd like, you can sketch another 2 points, which would be from the third step. That's how you would graph a parabola if you're given the vertex form. Oftentimes when you're given the vertex form, the zeros are a bit difficult to calculate. So there will be other methods of learning to graph a parabola. Just make sure that you're aware of which type of form you have your parabola in and which one would be most useful to graph in that case. Let's look at a couple examples here. First example, it says just to state the vertex axis of symmetry, the maximum or minimum value, the location of the zeros, and the y-intercept of this parabola. And just reading from this parabola, the vertex is at 3, 1. It is an opening up, and the lowest possible value is 1. So our optimal value is a minimum value of 1. The axis of symmetry goes through the vertex, so it is at x equals 3. The next thing is the location of the zeros. Well, since it doesn't pass the x-axis, there are no zeros. And the y-intercept looks like it's at between the 6 and the 7, so I would say it's at 0, 6.5. Example 2, it goes through quite a bit here on how to graph this parabola, and it shows you the steps as it does that. So I will just kind of go through this a little bit faster. Basically, our parabola here is represented algebraically as y equals minus 3, x plus 2 squared, plus 5. So our hk, because we have a plus 2, that means that our h value is actually minus 2. And our k value is obviously just 5. So our vertex is at minus 2, 5. So you would label that vertex on your Cartesian grid. So if you look at the image on the right, the vertex is labeled at minus 2, 5. Then we have to find the first step, and we would go 1 to the left, 1 to the right from the vertex. So if the vertex is minus 2, 1 to the left would be minus 3, 1 to the right would be minus 1. And we would have to add the a to the k value. So our k value is 5, so 5 plus minus 3 is 2. So we label those 2 points for the first step, minus 3, 2, minus 1, 2. Then we would find the second step, which is going to be at minus 4 and 0. And we would add not minus 3, but minus 3 times 3, so minus 9. So 2 plus negative 9 is negative 7. And we end up with points at minus 4, minus 7, and 0, negative 7. You can read through the steps there if you need more instruction on how to do that. That's basically, that is how you would graph a parabola from the vertex form. So for these support questions, the first one I will not go through just because it's just stating the location of those points. If you're having trouble with that, send me an email and let me know. I'll go through the second one because it's more important. I mean, it might be more difficult to notice these just from reading the algebraic expression. And then I'm going to sketch, I'll sketch 3b after that. So let's see, 2a says to state the vertex step pattern in the direction of opening of the following parabolas. So we have, for 2a, I have a step pattern. The a here is 0.5, so that means my step pattern is going to be a, 3a, 5a, so 0.5, 1.5, 2.5, just like that. My vertex is going to be at 1, 6, because it's minus 1, so it would be at positive 1, and then plus 6, so the y would be at 6. And the direction of opening, if the a is positive, then the direction of opening is simply up. Let's look at 2D. Here we have x squared plus 2. So if we wrote this in a bracket, it would be bracket x plus 0 bracket squared. So because there's a plus or minus 0, that means that our our x component of the vertex is 0, and our y is just the 2. So our vertex would be at 0, 2. The a is 1, so it would be the pattern for the step pattern would be 1, 3, 5, and it would have to open up because that a is positive. And now I'm going to graph 3b. So 3b, it says y equals 2x plus 1 squared minus 3. So let me pull up my graph paper here. And just so that this is grid paper. There is some grid paper posted on the course website. so you can make use of that. What we need to do here is figure out, before we start, let's just figure out what our vertex is going to be, and then we'll make our grid based on that. So our vertex will be at -1, -3. It's going to open up, and our step pattern is going to be 2 times 3, which is 6, and then 10, because 2 times 5 is 10. And it's going to go on and on like that. So knowing that I'm going to start in the third quadrant where we have 2 negative values, and I'm going to open up, I will make my Cartesian plane here, my grid, mainly on the left side. So here I'm going to just put a line down. I do have a ruler, so I should be using that. Now the lowest possible point, my optimal value is going to be -3. So I don't really need anything past -3. So I will start at -3, -2, -1. I'll make this my big 0 point. 1, 2, 3, 4, 5, 6, 7. And I'll make this my x. I don't really have to go much on the right side, so I'm just going to label a 1 there. -1, -2, -3, -4, -5, -6, and so on like that. Now, -1, -3 will be at this point. And if I go 1 to the right, I go up by 2. That's my first step. So 1 to the right, up by 2 gets me here. 1 to the right, up by 2 gets me here. And then another 1 to the right, I would have to go up by 6. So 1, 2, 3, 4, 5, 6. So this is my second step. And this is mirrored, so if I go to -3 on this side, I should also be at 5. That is enough points to make my sketch. So I need to then make my curve. So I'm just going to kind of go move up from here. Oops, that wasn't that great. I'm going to redo it. Unfortunately, I used pen instead of pencil. And then I have my 2 curves. Now I'm putting arrows at the end to represent that these lines go on even further than I've shown them. And what you should do at the end of one of your arrows is write down what the parabola equation is. -2 x minus 1 squared minus 3. Sorry, I think I had +2 or +1. And that is how I would represent my parabola. Let me show you what the assignment looks like for this. So for your assignment, you have one question where you're just stating the vertex, optimal value, and a number of other properties of a parabola from the image of a parabola, from the graph of the parabola, and then you need to write the equation that represents the parabola. So if you know the vertex and the step pattern of a parabola, you can write down the equation of that parabola in vertex form. And I mean, really, what you're doing is you're just thinking backwards. So I'll kind of leave that to you to figure out, but it's basically your step pattern. The first step in your step pattern is your A. And your H and your K can be found from the vertex. So just going backwards, you can write your equation for your parabola. So you'd basically have only 4 questions. You'll do that twice for 1. And then for 2, you're going to have 2 equations of parabolas. You just have to state the vertex, step pattern, direction of opening, and then sketch those parabolas on a Cartesian plane. And I do have grid paper available for you on the course website.